Hello and welcome to Unit 8 Opener number 1.5, where we're going to be solving a word problem which is going to lead to a system of equations, and we're going to solve that by graphing. Alright, so we have cyclist number 1 is at mile marker 10 and starts to pedal at a rate of 20 miles an hour. And we have cyclist number 2 is ahead of cyclist 1 at mile marker number 25, and they are pedaling at a rate of 15 miles an hour. Now the first part of this problem is to graph the equation representing the position of each cyclist versus time. And some genius has already labeled this graph for us, so I presume the bottom is supposed to be minutes, the x-axis there, based on those times, and the y-axis is supposed to be miles or the mile markers or something like that. Alright, well, it's worth taking 2 or 3 seconds here to write some equations. We're going to write an equation for cyclist number 1. So his distance would be, he's starting at mile marker number 10, and then he's traveling at 20 miles per hour. I guess we could get into a whole unit conversion thing here, but I don't think that's really worth doing. And then cyclist number 2 starts out at mile marker number 25, but he's going a little bit slower at 15 miles an hour. Alright, so we've got our two equations written. Now, if you just think about this intelligently for a moment, the two are how far apart when we started this timing. This guy's at mile 10, this guy's at mile 25. That would make them 15 miles apart. What is the difference in their speeds? Well, this guy is going 5 miles an hour faster than this guy. So there are 15 miles that cyclist number 1 needs to make up. And he's making up 5 of them every hour. So just using your common sense, I think you can see that this is going to happen in about 3 hours. If you look at our scale on this graph, you'll notice this doesn't go all the way to 3 hours. So what I'm going to do is I'm going to pause the video for just a moment, and I'm going to go ahead and make this graph. And we're going to talk about why this graph may not be all that useful. So give me just a minute here, and I'm going to make these graphs. Shazam! The graphs are made. So, as you can see, it does look like the green line is getting closer and closer to that red line. But it also looks like they're going to intersect somewhere that doesn't fit on this graph, somewhere out here. So it's important when you're doing these systems of equations to sort of think about where is the answer going to happen. So we could go back and we could cross out all these, well, probably those numbers. We could cross out all those. And we could redo the scale, and I don't think it's worth taking the time to do that. What I'm going to show you instead is how to use a calculator to solve this problem by graphing. So, here's the calculator, and I've actually already entered in the two different equations. And the way I did that was I went to y equals up here in the corner, and in y1 I put our first equation, 10 plus 20x, and in y2 I put our second equation, 25 plus 15x. And if I hit graph right now, I'm going to see a graph of 2 lines. There you go. And this graph is no more useful than the graph we had made by hand. I can see the 2 lines, but I certainly can't see where they intersect. And in fact, it's hard to tell whether or not they do intersect at all. So we need to change what we're seeing in this. And there are a lot of different ways to do that. One way is if we go into this menu here called zoom, there's a lot of choices here. So maybe one thing we could try doing is just zooming out and see if getting a wider view of this situation is going to be useful. Let's try that. So you hit zoom out, and then I'm just going to hit enter again. Oop, I hit enter twice. That's all right. So again, I'm not in love with the way this looks at all. I find it very difficult to see what's happening with these lines in here. So what I'm going to do then is I'm going to go to Window, and I'm going to change these numbers manually. So think about this. What x values do we care about? What values do we care about on this x-axis? Well, we certainly don't care about any negative numbers, because we're really starting our timer at 0 here. And then we need to go into the future. So I'm going to set my x minimum to 0. And I don't know, my x maximum, I mean, I'm talking about a bike race. How many hours do I really think will happen in a bike race? At least in a single day, maybe 10. Okay, now let's think about the y. We know we're starting at 10 miles, and this guy's starting at 25 miles, and we know they're going further than that. So I think we need to go up at least to 50 or 60 or 70, maybe to be safe. I'm just going to go all the way up to 100 like our original graph did. I don't really have a problem the way this y-axis was set up here. So going back to my calculator, I'm going to make the y minimum 0. Again, we don't really care about negative distances. It's not something we care about for this particular problem. And I'm going to go up to 100. Now I'm going to look at this graph and see how this looks. Now we're talking. 2 lines, one started lower, but it has a steeper slope. One started higher, but it has a slightly flatter slope, and those points meet somewhere right there. And you can find that intersection point on your calculator. And you'll notice above the trace button is the word calc. That's short for calculate. And what we're going to do is we're going to go into that calculate menu. So I hit second, and now I'm hitting trace. And you'll notice one of the options in the calculate menu is intersect. So I go down to option number 5, and I choose intersect. And I hit enter. And it asks me for the first curve, and let me just move left and right a little bit here. Where is my cursor? There she is. Alright, so it doesn't really matter where I am. It's just asking me what the first curve is. It doesn't really matter what I pick. I'm just going to hit enter. And you'll notice the cursor automatically switched to the other line. So now it's asking me for the second curve, and it's on the other line. So I can just hit enter. And it asks you for a guess. And that means it wants you to help it out. And it wants you to get that cursor kind of close to the place where they intersect. You don't have to be right on top of it, but it helps if you get kind of close. And you hit enter, and boom, there's the answer. X would be 3, Y would be 70. So that means it will take 3 hours, and they will be at mile marker 70 when it happens. Alright, so what's the big idea of this problem? What's the moral of this story? Well, the big idea is, first of all, you need to pick a reasonable scale. And if you're graphing something by hand, you really need to put some thought into what your scale is going to be before you start drawing it. Because otherwise, you end up with a solution that's off the graph, and you did all that work, and it didn't matter. I think another moral of the story, if you absolutely have to solve something by graphing, and you happen to have a graphing calculator at your disposal, that's the way to go. Graphing calculators do this quickly and easily. This is one of the things that they are really, really good for. You just have to know how to use it, and you have to know how to change that window to get an appropriate graph if you need to.